Hello, my dear students. Welcome back to our channel, motivus. We are discussing about the chapter some basic concept of chemistry. So we have discussed about law of chemical combination, average atomic mass, and we have dealt with mole concept, how we have to find out the number of moles. We are having three equations to find out the number of moles. If they have given the weight by molecular mass, you can get the number of moles. If they have given the number of molecules or number of particles, it can be atoms, it can be ions, it can be molecule, so you can use the equation n by na. If they have given the volume at stp, then you can go with the equation 22.4. So these are the three equations that we have dealt with in the previous lecture. Now what we have to talk is, we have to talk about the mass percentage. In this lecture, what all the things we are going to talk about, we will be discussing about mass percentage, or we can say that it is percentage composition. Then we'll be talking about empirical formula, we'll be talking about molecular formula. So these are the portions we will be covering in this particular lecture. Now what is mass percentage composition? So molecular formula for glucose, you know that is C6H12O6. Molecular mass of glucose is going to be 180 gram. In this, what is the number of carbon, what is the number of hydrogen, what is the number of oxygen you can able to get. Number of atoms of carbon is 6, hydrogen is 12, oxygen is 6. And atomic mass of carbon is 12, hydrogen 1, oxygen 16. So what I am trying to tell you is, one carbon is having atomic mass 12, and in glucose how much carbon atoms are there? We got 6 carbon atom. So what will be the total mass of carbon in glucose? That is going to be 12 into 6, 72. What is the total mass of hydrogen in glucose? That is 1 into 12, that is equal to 12. And what is the total mass of oxygen in this glucose? It is 6 into 16, 96. So how will be finding out the mass percentage composition? Mass percentage composition means the percentage composition of that particular element in that compound. Percentage composition is the amount or the percentage of particular element in a compound. So mass percentage composition can be found out by using the equation mass of atom by molecular mass into 100. Right? So mass percentage composition of carbon, hydrogen and oxygen can be found out. How? So first we have to find out the mass of atoms. Just look at that. If you got carbon, how many carbons you got? 6 carbons. So mass of atom is 6 into 12. That already we have found out. 6 into 12 is 72. So I am substituting that directly. 72 by molecular mass of the compound is glucose by 180 into 100. So percentage composition or mass percentage of carbon is 40 percentage. Likewise, we can find out for hydrogen and oxygen. Hydrogen 12 by 180 into 100. It's gonna be 6.67. Percentage of oxygen 100 minus 46.67, that is 53.33. What I have done here a little bit different. Yes, because you got only carbon, hydrogen and oxygen. So together these will be contributing to 100 percentage. Right. So we have found out the rest of the two. So if I add the rest of the two, what I'm gonna get? 46.67. The remaining who's gonna be remaining oxygen is there. So 100 minus 46.67, you'll be getting the percentage of oxygen. If you don't want to do like this, okay, go ahead with that percentage of oxygen. What you have to do? It's 96 by 180. So 180 0 0 0 180. Eraser, where is our eraser? Okay, so 96 into 1 by 180 into 100. So also you are gonna get the same value, 53.33. Okay, you got the point. This is how you have to find out the percentage composition. Mass of the atom by molecular mass into 100. So this is 1998 question. We'll be trying to sort it out. Hemoglobin contains 0.334 percentage iron by weight. They have given the percentage of iron in hemoglobin. Percentage of iron in hemoglobin. That means they have given us the mass percentage of iron. Right? They have given the mass percentage of iron. Just remember, the equation mass percentage is equal to mass of atom by molecular mass into 100. So mass percentage of iron they have given, how much they have given, it is 0.334 percentage. Now what we have to find out, look at that, we'll continue reading the question. The molecular weight of hemoglobin is given, the molecular weight of hemoglobin is given. Again, they have given mass percentage, they have given the molecular mass. And what they are asking, number of iron atoms present in one molecule of hemoglobin. They wanted us to find out the number of iron atoms in one molecule of hemoglobin. Let's find out that. Mass percentage, I'm going to write the equation. Mass percentage is equal to mass of atom by molecular mass into 100. Fine. I got the percentage composition already. So it's 0.334 is equal to mass of atom. Which atom we have to find out? Mass of the number of iron atoms they have to find out. We have to find out number of iron atom. You know the mass of one iron atom is 56. And I don't know how much iron is present in hemoglobin. Actually, you know that, but still we are gonna find out through this chemistry, right? So 56 is the mass of one Fe, and we don't know the number of Fe in hemoglobin, that I have considered as X, by molecular mass is 67,200 into 100. Now I can find out the X easily. What is X? 67,200 into 0.334 by 56 into 100. What is going to be this value? This is going to be big, very big. Whether any possibility? 56 and 672. I think there's a possibility. 56 and like we'll try this way. That's not possible, right? Sorry. 12 may be possible. Yes, 12 is possible. So 12 times we can cancel this. Okay, we will cancel this. Yes, let my PPT be clean. Okay, so we'll cancel this. How we are going to cancel? 56, how much time? 12 times in 672. Fine, 12 times. Then here 100 is there. You can write it as, you take the 0, so it is going to be 33.4. So 33.4 into 12 by 100. So you just multiply 334 into 4. Sorry, 334 into 12. I'm going to multiply. Four zero one eight. So 4018, and here one decimal is there, so it's by 100. 4018 by 100, it is 4.01. So you got the answer 4.01. You know, my PPT always look like this, but what to do? You got the answer, right? Just multiply and divide, you will be getting the answer. I know you got the answer even more faster than me, but that's good. You got the answer. A is equal to 4. So number of iron atoms, what we have found out? We have found out X. X is number of iron atom, that is 4. We got the answer, right? So this is how the question goes. So number of iron atoms present in one molecule of hemoglobin, I got it as F. So just remember the equation, mass percentage is equal to mass of atom. If we wanted to find out the number of atom, consider X into mass of one atom by molecular mass into 100. So you will be getting X as the number of atom. Then sometimes they will be asking a question, minimum molecular weight. So just if you wanted to find out the minimum molecular weight, consider you got minimum number of atom. Like when the we can say that minimum molecular weight is molecular weight of one atom. Whether it will be correct? What I was trying to tell you is molecular weight, minimum molecular weight, you have to consider the number of atom will be minimum molecular weight. Like for example, If you got Fe as 4 here in hemoglobin, what is the minimum molecular weight of hemoglobin? If the question was like that, what you have to consider, you just consider you got only one Fe. That is it. So actually in hemoglobin you got 4 Fe, but if I wanted to find out the minimum molecular weight, then consider I got only one Fe and solve accordingly. Yeah, I'll solve one question so you'll be getting more clarity. Look at that, this is 2001 question. Percentage of selenium in peroxidase anhydrous enzyme is 0.5 percentage. So they have given the mass percentage of selenium. Okay. And the minimum molecular weight of peroxidase anhydrous enzyme. You don't have to worry about this big names. We don't have to worry who it is. It is none of our business. We just have to find out the minimum molecular weight. Fine. Percentage of selenium in peroxidase anhydrous enzyme. Let's say percentage composition of selenium they have given it as 0.5 percentage. What we needed to find out minimum molecular weight. If we wanted to find out the minimum molecular weight, I told you what you have to consider. You have to consider you will have only a minimum number of components. Yes, I got only one selenium. If I got only one selenium, then I can say that I'm gonna find out the minimum molecular weight. So 1 into atomic weight of selenium, that is 78.4 by molecular mass. Minimum molecular mass is what we have to find out into 100. This is how the question goes. So minimum molecular mass is equal to 1 into 78.4 into 100 by 0.5. So it's gonna be, this can be written as 7840, right, by 5. Again 10 will come, right? 5 into 10 power minus 1, this 0.5 can be written as 5 into 10 power minus 1. That 10 power minus 1 will go to the numerator, again you will have this one. So what is going to be the value? Let's take a look at 1, then 2 is remaining 28, 5, then 3 34, 6, okay, 8, okay, then 2. So it's going to be 1 2 3 4. So I can write the final answer as 1.5682 into 10 power 4, right? Correct, Dana? So look at that, this one can be written as 1.5682 into 10 power 4. You got 1500 right? I think the option B is going to be the, not the B, not the B, not the B. Yes. Option, which option is going to be correct? The option is first option, 1.568 into 10 power 4. This is how you have to find out. I'll just tell you how to find out the minimum molecular mass. If you wanted to find out the minimum molecular mass, consider you got minimum number of atoms. Say they are talking about selenium, they have given you the atomic weight, they have given you the percentage composition. So consider you got only one selenium. Then solve. If they are asking you to find out the minimum molecular weight. Now we'll talk about vapor density. What is vapor density? Vapor density of a gas is the ratio of density of gas and hydrogen at same temperature and pressure. That is, relative density of the gas with respect to the density of hydrogen at same temperature and pressure. So what is vapor density? Is nothing but the density of gas by density of hydrogen at same temperature and pressure. This is very important. So this is what we are calling this vapor density. Relative density, if you wanted to find out the relative density, this relative density of any gas with respect to hydrogen is what we are calling this vapor density. If it is with respect to any other gas, we'll just tell it as relative density. Density of a gas A by density of gas B. What is specific gravity? It's nothing but density of solution by density of water. And you know, density of water at 40 degrees Celsius, it is going to be 1 gram per centimeter cube. So specific gravity, we can say that it is equal to the density of solution as well. So just remember the equation for relative density as well as the specific gravity. Now let's say vapor density is equal to molecular weight by 2. This is another important equation you should remember. Vapor density is equal to molecular weight by 2. And mole and volume relations we have already discussed in the last lecture. We are recollecting that here. The all conversion, 1 mole of a gas as 1 mole of a gas at STP occupies 22.4 liters. 1 mole of a gas at STP occupies 22.4 liters. because STP, standard temperature pressure, in the older convention, standard temperature was 273 Kelvin, standard pressure was 1 atm. At that time we used 1 mole of a gas occupies 22.4 liters at STP. But now new convention, according to new convention, 1 mole of a gas occupies 22.7 liters. Why? Because now STP condition is changing, temperature same, but the pressure we are considering as 1 bar. But of course we are solving the questions that somebody have prepared few years ago, so we'll be solving the question by using this equation to get the correct answer. V by 22.4. We are still using the old convention, we have to update to new convention. Well, let's see if NTA is updating with this, like in the question paper they would have mentioned if they are updated. Fine. Formula. So moles is equal to volume of gas at HTP by 22.4. So we are using this one always. Moles of gas is volume by 22.4. Look at this question. We'll solve this question. How we have to make use of the vapor density to find out the formula of the compound. The hypothetical gas they have given N2X. Fine. This is what the hypothetical gas they have given. Its vapor density is 70. We have to find out X. Okay, if you get the vapor density, then it's easy to find out the molecular mass, because 2 into vapor density is the molecular mass. So we can say that 2 into 70, 140 is going to be the molecular mass. Fine. N2, how many N2s are there with us? X N2s are there, right? X number of N2s are there. N2, what is the mass of N2? 28, right? So X into 28 is what 140 is. So what is going to be 140 by 28? 140 by 28 is going to be X. So I think 28 into 5 should get 140, right? Yes, that's correct. Good. X is equal to 5. So X you got. So if they have given the vapor density, convert that into molecular mass, then you substitute here, because N2 you already know the mass is 28. X is what you don't know. So X into mass of N2. So you will be getting the answer. You will be getting the answer as this one. Okay, clear? X is equal to 5. Now vapor density of a gas is 11.2. The volume occupied by 11.2 gram of this gas at STP. Again the question, they have given you the vapor density of a gas. Volume occupied by 11.2 gram of this gas at STP is what you have to find out. Volume occupied by a gas at STP. Fine. So vapor density they have given. From the vapor density we are going to find out the molecular mass. Vapor density into 2, that is 11.2 into 2. 11.2 into 2 is 22.4. Fine. Now what we have to find out? Volume occupied by the gas at STP. So what is the equation? At STP, number of moles is equal to V by 22.4. What we needed? V. V is equal to 22.4 into N. How should I know the N? I got the molecular mass, I got the weight, mass in gram. If they have given you the mass in gram, then how I can easily find out the number of moles. Number of moles is equal to given mass by molar mass. So it's going to be 11.2 by what is the molecular mass? 22.4. So I'm going to substitute this one. 22.4 into N is 11.2 by 22.4. Cool. We got the answer 11.2 liters. Where is the option? Here goes the option. You got clarity? Yeah, that's it. Then we have to discuss about the molecular formula and empirical formula. What is molecular formula? It is the chemical formula of the compound which gives the total number of atoms of each element present in a molecule. In a molecule, what is the actual number of atoms? That is given by molecular formula. We can simply say that actual number of atom present in a molecule. And what is the empirical formula? It is just a simple whole number ratio of the actual number of atoms present in a molecule. It is the formula of the compound which gives the number of atoms of each element present in a molecule in a simplest whole number ratio. Like in a nutshell, I can say that as we are discussing about glucose, this is the molecular formula of the glucose. That is molecular formula, actual number of atoms present in a glucose. Glucose contains 6 carbon, glucose contains 12 hydrogen, glucose contains 6 oxygen. So we can say that this is molecular formula. But empirical formula is the simplest whole number ratio of atoms present in a molecule. Yes, you know common factor is 6, so you are going to divide it by 6, so you're going to get CH2O. So this CH2 is going to be the empirical formula. I hope you got clarity. Molecular formula is actual number of atoms present in a molecule. Empirical formula is the simplest whole number ratio of atoms present in a molecule. Molecular formula and empirical formula. The relationship we have to find out. Molecular formula of glucose is, yes, we have discussed 6C6H12O6. The highest common factor is 6. So empirical formula is CH2O. Done. Molecular formula is equal to empirical formula into n factor. Here the n factor is going to be 6, right? 6 into empirical formula, you will be getting molecular formula. Just remember this is very important. Molecular formula is equal to empirical formula into n factor. So acetic acid, right? Acetic acid, what is the molecular mass? 60 gram. So acetic acid you can write as C2H4O2, right? C2H4O2. Now empirical formula, you got common factor. Which one is common factor? 2. So it is going to be CH2O. Look at that. Highest common factor is 2. So we are dividing. So we will be getting empirical formula 2. This is the mass of actual atoms present in a molecule. That is molecular mass. This is empirical formula, the simplest whole number ratio of atoms present in a molecule. This mass is empirical formula mass calculator from the empirical formula. What I am going to get? 30. What is going to be the n factor? What I have to do? Molecular mass divided by empirical formula. So 2. So you got the equation. If you wanted to find out n, how you will be finding out? Molecular mass by empirical formula mass. Okay. Now you got trouble. Sir, okay, I got molecular mass, I got empirical formula, I got empirical formula mass, and I got n. So I can get the molecular formula from the n. But how should I get the empirical formula? How will I determine the empirical formula? Here goes the method. They will be giving you the mass percentage or percentage composition. From that you can able to find out the empirical formula. Check whether the sum of the percentage is 100. All the percentage should be 100. That is, they might have given 72 percentage carbon, 28 percentage of hydrogen in a hydrocarbon. So it's together will come as 100. So we have to check whether it is 100. If sum is not equal to 100, just consider there will be some amount of oxygen left. So whatever, if you are getting 50 percentage carbon and 20 percentage oxygen, sorry, 20 percentage hydrogen, 50 carbon, 20 hydrogen, then 50 plus 20 70. So what is going to be the amount of oxygen? 30 percentage will be oxygen. Even if they are not telling you, you have to assume that the remaining percentage is going to be the oxygen. Percentage of oxygen 100 minus sum of the percentage of the given elements. Then what you have to do next? Divide the percentage of element by atomic weight to get the number of atoms. So percentage you have to divide by atomic weight. So you will be getting the number of atoms. The number of atoms obtained in the above steps are divided by smallest number to get the simplest ratio. You will be dividing with the atomic weight, but that may not be simplest whole number ratio. So you have to make it into simplest whole number ratio. If fractions are obtained, again, what you have to do? You have to multiply it with a suitable integer to get the whole number. This is the whole method you have to follow to find out the empirical formula from the mass percentage. Fine. So numbers are written to the side of the element to get empirical formula. Then if you find out the empirical formula, what do you have to do to find out the molecular formula? N into empirical formula. If you got the N, how you will be getting the N? Molecular mass by empirical formula mass that we have done. So you will be getting the N. So you will be getting molecular formula as well. So from percentage composition, you got the idea how to find out the molecular formula. From the percentage composition, first you have to find out the empirical formula. What you have to do? First divide with atomic number. Then if it is not a whole number, divide with the minimum value in that. Even if it is not a whole number, you multiply with an integer. So you can convert it into a whole number. If you go the empirical formula, what you have to find out? You have to find out the N. How you will be finding out the N? Molecular mass by empirical formula mass. Then if you got N, if you wanted to find out the molecular formula, empirical formula into N, you got the answer. Let's look at that. You can predict the empirical formula of this, right? H2O2. Common factor, highest common factor is 2. So HO is going to be the empirical formula. CH4. Now common factor is going to be CH4. C2H6, 2 is common, so CH3. C2H4O, so C1H2O. This is how you have to find out the empirical formula. Now I'm just trying with an example to calculate the empirical formula from the mass percentage. These are the mass percentage: carbon 40 percentage, hydrogen 6.67 percentage, and atomic weight. See, look at that. This sum is not 100. So what is the meaning? Yes, there is oxygen present. So remaining 53.3 percentage is going to be oxygen. Atomic weight of carbon is 12, hydrogen 1, oxygen 16. First, I wanted to find out the least ratio. What I have to do, you just divide the mass of carbon, the percentage of carbon with the atomic weight of carbon, the percentage of hydrogen with the atomic weight of hydrogen. So if you divide 40 by 12, 6.67 by 1, 53.33 by 16, you will be getting the least ratios. If you get the least ratio, what do you have to do? You have to make it in the simplest whole number ratio. What do you have to do? In these, which is the least value, you have to divide it with the least value. So 3.33 by 3.33, that they have written already, I don't have to. Come on. So 3.33, least value is 3.33. So you are dividing it with 3.33. So you got the whole number. So if you got the simplest ratio, simplest whole number ratio, carbon 1, hydrogen 2, oxygen 1. This is going to be the empirical formula. From this, how you will be finding out the empirical formula mass? You have to add how many carbon? 1 carbon into mass is 12 plus 2 hydrogen mass is 1 plus 1 oxygen mass is 16. So it's going to be 12 plus 2 plus 16. So it's going to be 30, it seems, right? So this is how you have to find out the empirical formula, right? So you got the empirical formula. What is the empirical formula? CH2O. Now, this is a homework you can do. You just try with this one and let me know whether you are getting the correct answer. Fine. Determine the molecular formula of the compound. You have to find out the molecular formula. They have given the percentage composition of hydrogen, oxygen, as well as the carbon. Find out the empirical formula. From the empirical formula, you can find out the empirical formula mass. They have already given you the molecular mass, so you can find out the N. N is molecular mass by empirical formula mass. So if you go the N value, what you have to find out the molecule, how you will be finding out the molecular formula? Molecular formula is N into empirical formula. Okay, try this one. So let me know that whether you are getting the answer, and if not, no worries, we'll be solving that in the next lecture. That's it for this session. So we'll be coming with the stoichiometry and the limiting reagent in the next lectures. That's it. Thank you. Thank you.